Today we will talk about the types of reaction and balancing chemical reactions. When we talk about the types of reaction, we will even discuss what is the predicted products that we can expect from the different type of reactions. And we'll talk about different type of reactions and then balancing them, and as well as the predicting the reactions. So now, what we have seen up to now is we have seen the elements, we have seen how are the elements organized in the periodic table, and then we have seen how those elements are bonded between each other. And we have seen that there are two types of bonding that we have discussed. There's the one that is known as the ionic compound, where the electrons are exchanged. So metals are willing to give the electron away, to lose the electron, and then non-metals are like to receive the electron or to gain electrons. Now in this case, what it is created are created two entities, which we know as the ions, that are with different charges. One is positively charged and the other one is negatively charged. And as a result of this two different charges, what is happening is that those two entities that are ions are attracted between each other, because you know, based on the general law of charges, the two opposite charges will attract each other. So the same thing is happening when we have a metal with a polyatomic. And as we said, polyatomic table is at your first page of the periodic table, and majority of them are negatively charged. So they are creating ionic compound. However, when we have two non-metals that are bonded together, what is happening with the electrons in those type of compounds, the electrons are shared between each other. So the electrons go sometimes to one atom and sometimes to the other atom, and they are shared in order to complete the outer shell with 8 electrons, which is known as the octet rule. Based on this, what do we see? We see that there are two main type of compounds. That is known as the ionic compound or molecular compound. Now, those compounds or elements are reacting between each other. So then, what what we see after that is we see different reactions, chemical reactions happening in between either the elements and or compounds. So the very first type of reaction that we see is when we have a formation or synthetic. So this is the first type of reaction. And now you may ask, like, why are we doing this? Because science is based on patterns, science is based on classifying stuff. We cannot say that, oh, here there are the reactions and you deal with it. But we classify them into groups that have main characteristics the same. So this is what we are doing here as well. So formation is when element A, the general form of it is when element A is reacting with element B to form a compound, okay, a compound AB. Perfect example of this is a metal and non-metal, or two non-metals that are formed, that are combined together, that are bonded together to form a compound, either ionic or molecular compound. The second type of reaction is decomposition, which actually is a compound broken down into elements. So the general form of decomposition will be a compound AB is broken down into element A and element B. The third type of reaction that we see a lot is a single replacement. What is happening during singular replacement is an element is in contact, and I will use in contact in quote unquote, in contact with a compound, and what is happening is the element is replacing the similar type of the element on the compound. So what do I mean by this? Let's say that a metal is in contact with an ionic compound. So what this metal is doing is taking the place of the metal on the ionic compound and creating a new ionic compound with the metal there. So the general form of it will be A plus BC, which is a compound, will be B on its own, the metal on its own, and a new compound AC. The fourth type of reaction that we see is the double replacement reaction. So two compounds, let's say one acid and one base, very typical double replacement reaction, are switching the metal and non-metal together, or hydroxide and whatever is making them as the acid. So now they are switching the places together to form two new compounds. Or when we have, let's say, an acid and base is the best example. Two ionic compounds, they are switching the metals and they are switching the non-metals together so that they are forming two new ionic compounds. Sometimes the acid and base reactions are called neutralization, because what is happening when an acid and a base are reacting together, it's a salt and water formed. The fifth type of reaction is combustion, when we have a hydrocarbon compound that is burned into oxygen to form carbon dioxide and water. Always the product of a combustion of a carbohydrate compound is giving us carbon dioxide and oxygen, except on the cases when we are dealing with not fully combustion, where we see carbon monoxide and water. And carbon monoxide, as you know, is very dangerous for our health. Now, the way that you remember those, or one way that you remember those, is imagine that all those elements and compounds are in a dance floor. And when a person when a boy usually goes to a girl or another person, then they dance together in a dance floor, and this is the formation. Or when two people are dancing in the dance floor, and then they are tired and they go to their tables. Or a couple or two people are dancing in the floor, and then one comes and replaces the lead of that couple that are dancing. Or two couple are dancing in the floor and they switch partners. And combustion is combustion. Okay, do you have any questions? Okay, so on the case when or examples that we see when we have formation is sulfur plus oxygen will give us SO3, okay, sulfur 3 oxide. So we're not balancing it for now. We will see the balancing in a bit later on. And now iron 3 and oxygen, as you may remember from what we said yesterday, iron is one of those that is known as the polyvalent or multivalent element. So what it is in this case, we are dealing with valence +3 of iron, and then oxygen being on the 16th place of the group of the periodic table will be having number of electrons in the outer shell is 6, which means that it's willing to take 2 electrons more. So now if we switch the places, what we will have is Fe2O3. So what is formed here is an iron 3 oxide. The name for it is iron 3 oxide. Okay. Now, when we see a singular replacement, again, it's the case, this is the case when two people are heading toward each other to go to the dance floor. Next one is when we have a singular replacement, the example of the singular replacement. So as you see here, lead, and lead, I think that is multivalent as well. Yeah, it's lead, and we will say that it is, let's say that this is a lead-2. Is reacting with phosphoric acid, and then what is happening here is lead, and again we are assuming here that is +2, and phosphorus is part of the polyatomic ion. PO4 is 3-, so if we switch the places, again, remember what we said about polyatomic, that they act as one group. So this will be PO4 2. So then what is created here is lead-2 phosphate and 3 PO4 2 and hydrogen. Okay, we are not balancing it for now because it is a bit, we will see it in a while. And now what we have here is lead-4 is reacting with iron-2 sulfate. Let's see what will be the products that will be created here. Okay, so what we have here is lead-4 is acting with iron 2 sulfate. Let's write the reaction for this one. So lead is Pb, and we know that is it's an element in the periodic table, and now we have iron 2 sulfate. So iron 2 will be 2+, is a multivalent, and the sulfate is in the periodic table under the polyatomic ions, and it is SO4 2 minus. So now we're switching the two coefficients and reducing them to the lowest term. This will be FeSO4. So lead plus FeSO4 will give us, since it is a singular replacement, what will happen? Lead will be replacing the iron here, and then we will have lead that is, remember what it was, is +4, and sulfate is still 2 minus. So replacing or putting the coefficients, switching and putting the coefficients down and reducing them to the lowest term, we will have PbSO4 2. So PbSO4 2 plus iron. Okay, so knowing the type of reactions helps us to identify what will be the products that we can have from this reaction happening. Now, when we have the decomposition, and again, when the question that Alejandro has, when we have this, why is this happening like this? I give you the products. So what is happening here is calcium carbonate is decomposing into carbon dioxide and calcium oxide. And now the next one is in words. So lead 2 sulfate, lead Pb2 plus sulfate. We said that it is SO4 2 minus. So the formula for this will be PbSO4. It is decomposed into lead 2 sulfite, and sulfite is SO3. So lead 2 Pb2 plus sulfite in your periodic table is SO3 2 minus, switching the places, making them to the lowest term. We will have PbSO4 decomposed into PbSO3 plus oxygen. Remember, oxygen is one of those compounds that it doesn't stand on its own. So it's hydrogen, it's H2, oxygen is O2, and then you have the table that from the previous lesson to memorize or to have it into your data booklet. Double replacement is calcium hydroxide and aluminum sulfate is reacting, and see what is happening here. Calcium is replacing the aluminum part of it, so metals are switched, and then two metals are switched, and then what is happening is that a salt is formed and a base is formed. So calcium hydroxide reacting with aluminum sulfate, it will give us calcium sulfate and aluminum hydroxide. Now, on both of those cases, calcium and aluminum are single valence, so we don't have to state the valence of each of those metals. Sulfuric acid and ammonium hydroxide are reacting together to form ammonium sulfate and water. I want you to write this chemical reaction from words into a chemical formula. And now, one thing in terms of the sulfuric acid or those specific names, you can find those chemical formulas if you do not know them. When on your data booklet, when you are looking at the page 8 and 9, where you have all the acids. So this page here, where you have all the acids. So find the sulfuric acid formula if you do not know what it is. Okay, on the chart, please tell me what is the sulfuric acid formula, what is the ammonium hydroxide formula, and what is the, how do we write this reaction? Okay, the way that you can find the formula for ammonium hydroxide is 2, NH4OH, yes. The way that you can find ammonium hydroxide is by using polyatomic. As you see, ammonium is part of the polyatomic, so it is NH4, and the charge is +1, and OH is -1, so this will be NH4OH. In some of the textbooks and some of the sites, if you search it, you will see it as NH5O, but actually this will show more understanding than what you believe that may happen. Okay, so now let's write the product, the formula for products. Water is, we know that, is H2O. And now what is the ammonium sulfate? So ammonium, we said that is NH4 1+, and sulfate is SO4 2-. So this will be NH4 2 SO4. Good. Okay, so then the last one is combustion. So we have C2H4 plus oxygen. That X and Y that we saw in the general expression of the combustion is when those X and Y are being different numbers. 1, 2, 3, 4, sometimes 10 or so. Plus oxygen, always we will not even think about it. The products will be carbon dioxide and water. So even if we have methane, so let's suppose that we have methane is burned, or the full combustion of methane is happening. What is the reaction? If you have a question like this, then you will write it as you see it here. Okay, so you should be able, based on this explanation and this short review, and I know that it is very short in comparison to what you have done on Science 10. However, this is just a reflection. You should be able to predict what are the products that are happening in this reaction based on the type of reaction that is happening. Let's move on now to those practice here. We will identify, first of all, what type of reaction is it and what will be the product, and what I want from you to communicate with me via chat, so that I know that you are being part of this conversation. So the first one is a double replacement reaction. How do we know that is a double replacement? We have two compounds that have two parts, one positive, one negative, that are reacting between each other. So what do you think that the products will be on this case? What are the products? English name of the products that are formed here. So the English name of it is magnesium carbonate and lithium chloride. The chemical formula is MgCO3 and LiCl2. Yeah. No, Cl. Just Cl. Okay, let's move now to the third example here. What type of reaction is this one? Talk to me on the chat. Combustion. Okay, as soon as you see C and H with some numbers that reacting with oxygen, or it is burning, or it's fully combustion, or things like this, then you are dealing with a combustion. And you don't even have to think about it, but then you go CO2 plus H2O as the product of it. Carbon dioxide and water. Good. Next example that we see here is what type of reaction? Single replacement. Good. Single replacement. What is formed here is a lead, sulfate, and iron. Now, we don't know what is the valence lead has. Let's say that is lead 4. And then we can write the formula for this as well. So we are assuming here that lead is 4. Write the formula, please, and tell me on the chart. Good. So when we are saying it in English, we may say lead 4 is reacting with iron 2 sulfate to form lead 4 sulfate and iron 2. Okay, how do we know that iron is 2? Because we see the chemical formula of iron sulfate, and then this tells us that iron is with 2, with a valence of 2. Okay, let's move to the next example here. Calcium carbonate. What type of reaction is this? Guys? Decomposition. Good. It is decomposed into simpler elements, let's say. And what about the next one? P4 plus O2, formation. Good. Formation. What is the other one? What type of double replacement? And what is the next one? Single replacement. Yeah. And what is the other one? What is this one here? Not combustion. If it was O2, then would be combustion. But since it's single replacement, yes. What is this one here? Single replacement. This is not a hydrocarbon compound. So single replacement. And what is this one here? Double replacement. Okay. I have any balancing chemical reactions is important. Is important because what we are honoring on balancing chemical reactions is we are honoring that is known as the conservation law of masses, and this is one of the main principles of life, let's say, but science in general. What the conservation law of masses is saying that the mass is not created and is not destroyed, but it is transformed, is not created, and it is not destroyed. destroyed, but it is transformed from one form to the other. So what it is saying that if two elements or compounds are bonded together to form some other elements or some other compounds on the other side of the reaction, the mass of the atoms in one side has to be equal to the mass to the number of atoms on the other side. If we have, let's say, 5 of one type of atom in one side, then we should have 5 on the same type of atom on the other side. Now you know that the chemical reaction has two parts: is the reactant and the reactant and products. So the mass of atom, the number of atoms on the reactant has to be the same as the number of atoms on the product. Now let's see and observe what is happening here on those cases here. When we have sodium and oxygen are reacting together to form sodium oxide. Now, if we are going to classify this reaction, this will be a formation reaction because two elements are reacting together to form a compound. But let's see now, what do I mean by balancing and the number of atoms. If we see sodium here, it is only one atom of sodium that is on the reactant part. And this is products. So now it is only one atom. And if we see sodium on the side of the product, then we have two, because this little 2 here means that we have 2 atoms of sodium that are on this ionic compound. So therefore, the number of atoms for sodium on the reactant part is not the same as the number of atoms of sodium on the product part. Let's observe oxygen here. Oxygen in the reactant has 2 atoms. How do we know? Because it's of this little 2 that oxygen has. But when we observe it on the other side, then we see that we have only 1 oxygen. So as you see here, number of atoms of the same atoms in the reactant side is not the same as the number of the same atom on the product side. And in order to honor the conservation law of masses, we have to equal those number of atoms together. But how do we do this? Sometimes what the students do, they just cancel 1, 2 here or cancel the 2 here. That is not correct. The way that we balance chemical reactions is by adding coefficients in front of either the element or the compounds. And the coefficients are numbers that are placed in front of the elements here. Okay, so the number of large numbers, not those numbers that you see here for oxygen or for sodium. So now, a strategy that is used widely to balance chemical reactions is by writing the left side and the right side, or reactants and products. Sometimes they say left side, sometimes they say reactant, and then left side or reactant, right side or products. And then they sort all of the elements that atoms that you are dealing with. So on the reactant, as we said, we have 1 sodium and we have 2 oxygen. And on the product side, we have 2 sodium and 1 oxygen. So now the question is, what do I have to do to 1 oxygen here to make it 2? Okay, I have to multiply this by 2. Okay, so what I will do is I will go to the product side, and in front of the compound that has oxygen on it, I will add a 2. Okay, so this is what I mean by adding the coefficients. By adding this 2 here, by adding this 2 here, what we are doing is we are affecting sodium now. So by adding 2 in front of the oxygen or the compound that has oxygen, what we are doing is we are affecting the number of atoms for sodium. So now sodium is becoming 4 because 2 times 2 is 4. So therefore, to balance the sodium on the other side of the reactant, on the reactant side, that is 1 now, what do we have to do is we have to multiply it by 4. And multiplying it by 4 means that we will add a coefficient of 4 in front of the element or the product that has sodium on the reactant part. And in this case, we do a final check. We see what is everything balanced. So we have 4 sodium on the reactant, 4 sodium on the product, 2 oxygen on the reactant, 2 oxygen on the product. Do you have any question? Let's try to balance now the second example here. So again, what we will do is we will work with a table. You can say the reactant or left side, the product or right side, it doesn't really matter. The atoms that are participating in the reaction are nitrogen and oxygen. So nitrogen and oxygen are forming dinitrate pentoxide. In the reactant part, what we have is 2 nitrogen and 2 oxygen. And on the product side, what we have is 2 nitrogen and 5 oxygen. Now, as you see here, nitrogen and is balanced because we have the same number of atoms in both sides of the reaction, on the reactant and on the product side. However, oxygen is not balanced. Tip that I use when I see those numbers, so you see a 2 and 5, then what I do is, like, it doesn't matter how many times you are working out with 2, you cannot make it 5 with multiplying or dividing it by whole numbers. However, if you multiply both of them, the product side by 2 and the reactant side by 5, then you will have 10 on each side. So see what do I mean by this? So the product side, we know that is product. The compound that has oxygen on it will be multiplied by 2, or we'll add the coefficient of 2. And then the element or the product that has oxygen on the reactant side will have a coefficient of 5. So now oxygen is balanced. 2 times 5 is 10 and 2 times 5 is 10. However, by adding this 2 on the product side, what we are doing is we are making nitrogen here, we are making it a 4 because 2 times 2 is 4. And then in order to balance it, what do we have to do is we have to multiply 2 by 2 to give us 4, which is translated into adding the coefficient of 2. And then after that, you do a final check and say 4 nitrogen, 10 oxygen, 10 oxygen. Okay. So the next one is sodium hydroxide is reacting with carbonic acid to form sodium carbonate and water. So let's try to balance it. We have the reactant and product side. And see here, hydroxide is not saving the same format on the other side of the product. However, carbonate is saving it. So a strategy that we use on this case is we keep the carbonate as carbonate and not break it into carbon and oxygen. Why is this? Because carbonate is carbonate, the same structure, the same form in both sides, in the reactant and in product. So when we write the atoms that we are dealing with, and this is happening usually with polyatomic, even though that hydroxide is a polyatomic, but in this case is an acid and a base reacting to form salt and water, as we said before. So now oxygen, hydrogen, and carbonate. Okay, so on the reactant side, we have one sodium, 1 oxygen, and then see now we have 1 hydrogen here and 2 hydrogens here, so will be 3, and 1 carbonate. On the product side, we have 1 carbonate as well, and then we have 2 hydrogen, we have 1 oxygen, and we have 2 sodium. Okay, so how, I will leave it up to you. How can you balance it? And tell me what is the coefficient here, coefficient here, coefficient here, and coefficient here. Now write it into the form, whatever is on the first, second, and the third and fourth compound. What is the coefficient in front of each of them? If I was doing this from scratch, what I will do, I will start with sodium here, multiplying it by 2, so adding the 2 here, the coefficient of 2 here. And what do we see on this case? We make the oxygen as 2 and we make the hydrogen as 4. And in order to make the hydrogen 4 on the other side, what do we have to do is we have to add a coefficient of 2 here. And on this case, all of them are balanced. So we'll have 2 sodium on the reactant, 2 sodium on the product, 2 oxygen on the reactant, 2 oxygen on the product. 2 hydrogen plus 2 is 4. 4 hydrogen are here, and then 1 carbonate here, 1 carbonate here. Understand? Let's take a look on the other one. And see, this is again an example of a double replacement, that specific case of acid and base, that a salt and water is formed in the product side. So there are cases like this where that we see that the reaction is already balanced. So what do we see on this case is we have 1 potassium here and 1 potassium here. We have 1 oxygen and 1 oxygen in both sides. We have 2 hydrogens and 2 hydrogens here. And we have 1 bromine and 1 bromine. So when we do that reactant and product side, we sort everything. then we will notice that they are all balanced. And on this case, if this was a numerical response on your test, then what you will write is just 1, 1, 1, 1. Okay, we do not write it here, but as a numerical response, you should record the value of 1. It's kind of the placeholder. Okay, so let's take a look at this reaction here. I will erase that part that we have there so that we have some space to work on, and then let's balance it together. Every time that you have to do this, what do is you add that odd number to the oxygen and then multiply everything by 2. So this is 2 and this is 8. So the balanced equation will be 4 FeS2 plus 11O2 will give you 2 Fe2O3 plus 8 SO2. And now let's double check. We have 4 iron, 4 irons, 8 sulfur, 8 sulfur, 11 times 2, 22, and oxygen, so 2 times 6 is 2 times 3 is 6, plus 14 is 22. And this is the balanced reaction. Just to summarize it again, so we start with balancing iron, then what do is we multiply it by 2 by adding a coefficient of 2 in front of the compound that has iron on it. By adding that coefficient, we are affecting the number of atoms of sulfur, and we are making it, instead of 2, we are making it 4. What do we have to do to make sulfur 4 on the product side? We multiplied by 4, so we had 2, 4, we multiplied by 4, and by doing so, we are affecting the oxygen, which now becomes 4 times 2, 8, plus 3, 11. And when we reach that point where we have to balance oxygen, that is, in one side is odd and on the other side is even number, what do is that we put that odd number in front of the oxygen and multiply all the other coefficients by 2. We kind of think that, okay, if oxygen was not O2 but was just O, what will happen? Everything will be balanced. So since it is O2, we multiply everything by 2. After this example, you can click on the simulation to practice, or you can practice on the questions that are here. And this is the end of lesson.